Hi, this is Dr. John Bergduff. In this video, I want to show you an example of an application problem using fractions and how you might be able to approach it in an upper elementary grade. If I was giving you this same problem intended for a high school class, we could use algebra and the idea of a variable. X could be the unknown. But in the upper elementary grades, 5th, 6th grade, in that area, we don't really have the concept of a variable precisely. So I'm going to approach this from that point of view. Let's read the question. Abigail gives 2/3 of her Easter eggs to Byron. Byron gives 1/3 of the eggs he received to Celia, and Celia gives 1/4 of those eggs to Derek. Derek ends up with 4 eggs. How many eggs did Abigail start with? That's a pretty complicated statement. Let's see if we can restate it by trying to compare what Derek ended up with what Abigail started with. We don't know how many she started with. But looking at it sort of backwards from Derek's point of view, Derek ends up with 1/4 of the eggs that Celia got, which is 1/3 of the eggs that Byron had, which is 2/3 of the eggs that Abigail has. So he has 1/4 of 1/3 of 2/3 of what Abigail has, Abigail's eggs. Let's translate that using a couple of key words. Has is basically equivalent to an equal sign, and we've seen elsewhere that the word of in the context of fractions represents multiplication. So if we know that Derek ends up with 4 eggs, and that what he has is equal to 1/4 of 1/3 of 2/3 of Abigail's eggs, we would say that those 4 eggs is 1/4 equal to 1/4 times 1/3 times 2/3 of whatever Abigail has. Now again, in a high school class, we could use a variable like X, but we're going to use a more simple idea and just say it's a box. I don't know what goes in that box. 4 is equal to 1/4 times 1/3 times 2/3 times what? What goes in the box? Let's rewrite that just so we can have a clean copy. 4 is equal to 1/4 times 1/3 times 2/3 times whatever goes in the box. That would be the number of eggs Abigail has. Let's start by multiplying the fractions together. That's easy enough to do, especially if you notice first that there's some simplifying you can do. The denominator of the first fraction, the 4, factors as 2 times 2, so that the 2 in this numerator can divide one of the 2's in 2 times 2 and leave me with a factor of 2. Then multiplying the fractions, we multiply across the numerators, we multiply across the denominators. 1 times 1 times 1 is 1. So 4 is equal to 1 on the numerator, and in the denominator, 2 times 3 is 6, times 3 is 18. 1/18 times what? Now, again, we're not in high school at this point, so we don't really have notions of solving equations yet, but we do have what we think of as the missing factor definition of division. That when you're asking yourself 1/18 times what would equal 4, that's the same thing as asking 4 divided by 1/18 equals what? That's the missing factor approach to understanding division. That missing factor is 4 divided by 1/18. 1/18 times what would give you 4? What that means is that this whole question boils down very simply to what is 4 divided by 1/18? Let's go to a clean slide and see what that would be. Now, dividing by a fraction, you take the first fraction, which you could think of as 4 over 1. I don't think we'll need the over 1, so we'll just leave the 4. Multiplied by the reciprocal of the second fraction. So I take the second fraction, flip it over. 1 over 18 becomes 18 over 1. 18 over 1 is just an 18. So we're really just looking at 4 times 18. 4 times 18, maybe you get out your trusty calculator. That turns out to be 72. That's the number that was in the box. So if we go back to the original question just to remind ourselves what it is, the question in the beginning was how many eggs did Abigail start with? This is our answer. Abigail had 72 eggs. Nice example of an application problem using multiplication and division, but handling it at a level that would be appropriate to the upper elementary grades. Thank you very much.